Guys, as promised, our last lesson of the chapter. We're staying on track. Hopefully you have your note pack at home with you. If not, it is posted on Schoology, but we have one more lesson to talk about. And this week we've been talking about sample means. And today we're going to specifically focus on the difference of means. This is very similar to when we talked about the difference of proportions in the first half of the chapter. So we're jumping right in. We're still talking about ACT scores. We have two new schools that we're going to talk about, Ardrey-Kell High School, and who has scores that are normally distributed with a mean of 26 and a standard deviation of 3, and ACT scores at Providence High School are skewed to the right, just like LaSalle, with a mean of 25 and a standard deviation of 5. So we are going to randomly select 25 students from Ardrey-Kell High School and 30 students from Providence High School. And we are going to describe both of their distributions side by side. So for Ardrey-Kell, the shape, they tell us in the description, is normally distributed. And because our population is normally distributed, then our sample can be also called approximately normal. Okay. As for Providence, we know it's skewed to the right, but because our sample is 30 and 30 is greater than or equal to 30 by the central limit theorem that we talked about yesterday, it is approximately normal. For both distributions, the mean, remember the average of the sample means is equal to the population mean. So for Ardrey-Kell, this should be 26. And for Providence, this should be 25. And then our standard deviation, remember standard deviation for a sample mean is the standard deviation of the population over the square root of whatever your sample size is. So here it'll be 3 over root 25. And that should come out to 0.6. And then for Providence, we're going to do the same thing, which will be 5 over the square root of 30. Make sure you're changing your sample size for Providence. And this comes out to 0.91. So these are just our descriptions of our two sampling distributions of X-bar for our two different high schools. But now we're going to describe the distribution of the difference in ACT scores. So again, we've talked about this with proportion, and think back to how we solved for these things using the proportion values. So the mean, just like with proportions, we're going to just subtract our two means. So 26 minus 25 gets us a new mean of 1. And remember, that's the mean of the difference between the scores. So if we take a sample from Ardrey-Kell and a sample from Providence High School, on average, the difference between those sample means is going to be about 1. For standard deviation, we're going to do 0.6 squared plus 0.91 squared for a 1.09. And the shape, it's specific. Remember, we have to think about how we described both of our individual samples. This goes back to when we were talking about Skittles versus M&Ms. We compared how Skittles, what their shape was, and we looked at the M&M shape. And because they were both normal, we could say the difference is normal, and that's the same here. So we can say the difference between the means will be normal because both sampling distributions were approximately normal. All right, but just like with Skittles and M&Ms, you have to check that both satisfied that. So now I want you to take a minute to calculate the probability that random sample of our 25 Ardrey-Kell High School students has a higher mean ACT score than a random sample of 30 Providence High School students. Okay. So what this looks like, we've got our bell curve. It's normal, mean is 1, standard deviation of 1.09. And I just want to know that the probability of the difference So x bar of 1 minus x bar 2 is greater than 0. So your mean is at mean is at 1. We want to know what's the probability that it's greater than 0. So I'll let you take a minute, solve that, and then come back, check your answer. So you should have done z equals 0 minus 1 over 1.09 to get a z-score of negative 0.92. From table A, you would have gotten 0.1788. Subtract that from 1, and you should have gotten 0.8212. Okay. Remember to have drawn your bell curve. Remember to have your z-scores written down. Okay. So the big ideas for today, I will finish writing them out, but it's all about the sampling distribution of the difference. So I'll write them out and post the answer key, and you can copy those. I do want you to do the check your understanding before our next class so we can check that all together. All right, have a wonderful rest of your virtual day, and we'll see you guys in class soon.